Right. So linear programming, any idea? Have you all learned about this? Have you all heard about this? No. Right. Now we learned something called limiting factor analysis, right? Yes. What did we do in that? Limiting factor analysis means what? Come on. In limiting factor analysis, what did we do? At a time, if we have only one limiting factor, okay, at a time, if we have only one limiting factor, how to find that optimum production plan? So that's what we did in limiting factor analysis. Let it be in P1, let it be in BA2 or IMA, we learned the limiting factor analysis. So in each question, how many limiting factors you had? Only one. Only one. But when it comes to the real world context, there can be multiple limiting factors at a time, right? Yes, more than one limiting factors can be there. So if you have more than one limiting factors, if you have multiple limiting factors at a time, how to find that optimum production plan, right? So in order to find that, we are using something called linear programming. So this linear programming is a mathematical approach, is a mathematical technique which we use to find the optimum plan if we have multiple limiting factors. If we have multiple limiting factors. So let's get the understanding with the question number 1. A Limited is manufacturing two products called X and Y. The following are the resource usage of the products. Labor hours, okay, fine. Machine hours, contribution per unit. However, the company has the limited labor hours of 24 hours and machine hours of 20 hours, right? Find the optimal production plan which will maximize the contribution and state the contribution value that will be generated, right? Okay, fine. So let me, in order to make it easier, let me give you a rough example. Now let's assume let's say you have 1,000 rupees with you. You have 1,000 rupees with you, right? Using this 1,000 rupees, you have to purchase the goods. Let's say in the market there are two types of goods, A and B. A and B. Got it? A's cost is 200 rupees. If not, let's make it as dollars, $200. Each unit of B cost around $250. 250. A 200. Okay. Now you have only 1,000. You have only 1,000. Limited the? Yes. Now, now you have only 1,000. So using this 1,000, you can end up with purchasing only A, if not only B, if not you can go for a mix. Got it? Yes, right. If you are purchasing only A, how many units you will purchase? 5 units. How did you find that? 1,000 divided by 200, which means 200 into 5 will be equal to 1,000. Yes or no? Yes. Then 200x. 200x units. Right? 200x. One cost around 200. You have to find how many x. Right? If you are purchasing only B, how many units you will buy? 4. Which means 1,000 divided by 240. Then 240 into 4 will give you the cost of 1,000. Yes or no? Then which means 250 Y. You have to find how many Y's. One is costing around 250. If you are going for the combination, some amounts of X you can purchase plus some amount of Y you can purchase. Yes or no? Yes or no? It should be equal to 1,000. Got it? It should be equal to 1,000. In a more better way, it should be equal or less than 1,000. Correct? Equal or less than 1000, equal or less than 1000, which means in order to purchase these X and Y products, you can spend up to 1000. Maximum you can spend 1000, but you can spend less than 1000 also. It's up to you, right? So it will be 200x plus 250y equal or less than 1000. Yes or no? Yes or no? So for this formula, we call it as constraint formula. Constraint formula. Did you all understand the way I constructed this formula? Got it? Yes? Right. So using this constraint formulas only, we will be doing the calculation. For each and every limiting factor, we have to construct separate constraint formulas. After by solving that separate constraint formula only, we have to do the calculation. Got it? Right. So let me start with the question number 1. It's a basic question just to give a rough idea. Bit technical, you got to be focused. If you get any doubts, you can ask. A Limited is manufacturing 2 products called X and Y. The following are the resource usage of the products: labor hours, machine hours, contribution per unit. However, the company has the limited labor hours of 24 hours and machine hours 20 hours. So labor hours, when it comes to X, it takes 3 hours. Y 4 hours. Machine hours, it takes 5 hours. Y 2 hours. Contribution per unit, X per unit is $4, Y per unit is $5. Right? So we have to find the optimum production plan, which will maximize the contribution and state the contribution value that will be generated. Got it? Yes? Right. Okay. So now how many limiting factors are there? 2 limiting factors. So we have to construct 2 different formulas. Yes or no? One is for labor hours. Another one is for machine hours. Another one is for machine hours. Right? Now tell me, using the labor hours 24 hours are available. Using those labor hours, if you are producing only X, how many units you will purchase? How many units you will produce? 8, which means 3 into 8 will be equal to 24. Yes or no? Then which means 3x. Got it? Yes. If you are producing only Y, 6, which means 4 into 6 should be 24. Then 4y. 4y. Correct? Equal or less than 24. You can produce both X and Y. Somehow the resources will be 24. The labor hour consumption should be equal or less than 24. You can use up to 24, if not less than 24. It's up to you. Right? Machine hours. Construct the formula. Construct the formula. Machine hours. 5x plus 2y. Not the number of units. Our number of units we are represented by the alphabets. Here you have to take the machine hours or labor hours. Got it? So it will be 5x plus 2y equal or less than 20. Got it? So for 1 unit of X, you will use 5 hours. You have to decide how many units of X. For 1 unit of Y, you will use $2, 2 hours. You have to decide how many units of Y. Got it? Right. So these are known as constraint formula. What formula? Constraint formula. So this is your formula 1. This is your formula 2. Now what we have to do? In order to solve this? Using the simultaneous method. Right? So this is your first formula. This is your second formula. So in order to do the simultaneous method, there should be a common factor, right? Do we have any common factors here? No. What we can do? We can multiply this second formula by 2 and we can make this y as the common factor. Yes or no? So first of all, second formula into 2. So 2 into 5x plus 2y equal or less than 2 into 20. Got it? Right. So 2 into 5x it is 10x plus 2 into 2y it is 4y equal or less than 40. So this is your third formula. This is your third formula. Got it? Now what we have to do? From the third formula, you deduct the first formula, right? So from the third formula, you have to deduct the first formula. So 10x plus 4y minus 3x plus 4y equal or less than 40 minus 24. So 10x plus 4y minus into 3x, it will be minus 3x, minus into plus 4y, it is minus 4y. So plus 4y minus 4 will be eliminated. Equal or less than how much? 16. 16. Which means 7x equals 16. Then x equal 16 divided by 7. How many units? For 2 decimal places. 2.29 units. 2.29 units. Clear? Yes. Now in practical world, do we have in decimal places number of units? No. But for this question, you are getting the values like that. Okay. Right. So now x we have found. X we have found. Y. Now in order to find y, what can we do? We can substitute this x value for one of these three formulas we have. Yes or no? Yes. So for which formula we are going to substitute? Shall we substitute for the first one? Then it would be easier for us. So x equal substitute x equal 2.29 to the first formula. So 3x plus 4y equal or less than 24. 3 into 2.29 plus 4y equal or less than 24. So 3 into 2.29, how much? 6.87. So 4y equal or less than 24 minus 6.87. Correct? Yes. So 4y equal how much? 17.13. Then y equal 17.13 divided by 4, how much? 4.28. Then 4.28. 4.28. Got it? Yes? Right. So people, now you have limiting factors. Yes or no? You have three options. What are the three options? You can produce only x. Got it? You can produce only x. If not, you can produce only y. If not, you can go for the mix. Right? You can go for the mix. If you are going for the mix, x how many units? 2.29. Y how many units? 4.28. 4.28. Right? 4.28. So now we have to find the optimum production plan. Optimum production plan. Right? So here, now here labor hours also limited. Machine hours is also limited. Okay. So your optimum production plan will be X. How many units? 2.29 units. Y how many units? 4.28 units. This will be the plan which will give you the maximized contribution. Got it? Yes, if you calculate the contribution for this plan, it will give you the maximum contribution. Got it? Yes, right. So I'll prove that. I'll prove that. So your optimum production plan. Optimum production plan will be X 2.29 units, Y 4.28 units. Got it? Yes, right. So first of all, write this answer. After I'll come. Now you might be thinking, sir, how are you telling this will give you the maximum contribution? Why can't you get the maximum contribution if you produce only X? Can no can't? We have to check. Can't you get the maximum contribution by only producing Y? Can no can't? Won't it maximize the contribution? We have to check. How to check that? Later we'll check. Right before that you can write this. Okay. So now people, now we have constructed these constraint formulas. No, using these constraint formulas, we can't find the optimum production plan. We can't find the optimum production plan. Using these constraint formulas, we can find the mix. Okay, when there are two limiting factors, we can find the mix. Okay, we can find the mix. So you asked me for three products, right? Three limiting factors we can use, but we can't use for three products. If three products we can't use. Three limiting factors we can use, three products we can't use. There's a reason. Wait. Now here, now these are the limiting factor constraint formulas. Yes or no? Yes. Now I told you X and Y how many units to produce. Why can't you produce only X? Can't you produce only Y? If you are producing only X, if you are using the labors, you can how many units you can produce? 8. If you are using machine, how many units? 4. Now how many units you are going to produce? 8 or 4? So in order to find that optimum production, in order to find that units, how many X, how many Y, right? In order to find that mix and everything, people, we have to use something called linear programming graph. Using that graph only we can find how many units of X and how many units of Y, how many units of Y and how many units of X. If we are going for the mix, at which point we have to go for the mix, right? What are the feasible, suitable options? Everything we can find, right? So let me construct the graph for you. Now, if we are using a graph, tell me how many axes are there? 2 axes. 2 products will come for 2 axes. Then can we use for 3 products? 3 products we can't use. That's the limitation of linear programming. Got it? Right. So let me draw the graph. This is your y-axis. So y-axis, I am using the product y. Yeah? X-axis, I am using the product x. Right. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 0. X-axis I am using for product X. Okay. 1, 2, 3, 4, 5, 6, 7, 8. This is your x-axis. Okay. Now what we have to do, we have to draw the two constraint lines. For the labor hour, a line should be drawn. For the machine hour, a line should be drawn. Right. Now, first of all, labor hours. If you are producing only X, how many units you will produce? How many units you will produce? 8. Keep the coordinate here. If you are producing only Y, how many units you will produce? If you are producing only Y, how many units you will produce? 6 units. Keep the coordinate here. Now you have to match these two coordinates. You have to match these two coordinates. It's not a curved line, it's a straight line. Huh? It's a straight line. Huh? Right. So this is your, again, it's still like rainbow එකක් වගේ. Right. Okay. Still little bit. Okay, fine. So this is your labor hour line. Labor hours. This is for labor hours. Got it? Right. Now, if you are using machine hours, now use the machine hours. If you are producing only X, how many units? 4. If you are producing only Y, how many units? If you are producing only Y, how many units? 10. Right. So if you are producing only X, how many units? How many units? 4 units. If you are producing only Y, how many units? If you are producing only Y, how many units? 10 units. Correct? Right. So now you have to connect these two dots. It's a straight line, huh? Like this one. Still it's going like that. Okay, fine. Okay. Right. So now what is this line? This is your machine hours. Correct? Right. Now, what is this point? At this point, you are producing the mix of X as well as Y, right? Yes. This is the point where both the limiting factor lines are getting intercepted, getting cut. So at this point, you are producing the mix of what? Both X and Y. So Y how many units? Y, this is the units. X how many units? X, this is the units, right? We use the simultaneous formula and we found how to find how many units X and Y using that method. Using that simultaneous formula, we can find the mix. So X how many units? 2.9. Y how many units? 4.28. If you draw the graph properly, these things will be straight line. Properly it will be there, right? Okay, fine. So now you can produce 6 units of Y, right? So you can, according to labor hours, you can produce 6 units of Y and 8 units of X. According to machine hours, you can produce 10 units of Y and 4 units of X, correct? Right. Now tell me, ideally, actually, can you produce 10 units of Y? Can or can't? You can't produce 10 units of Y. Why? What's the reason? Because labor hours are here. See, labor hours up to 6 units only you have labor hours, right? Can you produce 6 units of X? Yes, machine hours is also there. Here, see, this is the machine hour line. This is the labor hour line. So at this point, you have unlimited machine hours, but labor hours up to this point it will be there. Can you produce 8 units of X? You can't. Why? Because the machine hours are limited. Can you produce 4 units of X? Yes, you can produce 4 units of X. So these are the feasible points. This point I mark it as A. This point I mark it as B. This point I mark it as C. These are the feasible points. So these 3 are the options which we have in order to do the production. Clear? So point A people, what's the point A? 0 units of X and 6 units of Y. 0x plus 6y. Clear? Got it? Right. So I'll write like this, if not you will get confused. So when it comes to A, X 0 units and Y 6 units. Correct? Right. At the point B, how many units? 2.29 units X and Y 4.28 units. At the point C, how many units? 4 units of X, 0 units of Y. X 4 units and Y 0 units. So these are the feasible, possible production. So for these points, we call it as feasible options, feasible points. Clear? So A, B, C, A, comma, B and C, we call it as feasible options. Feasible options. Clear? For this area, for this particular area, we call it as feasible area. Can you produce 5 units of X? Y? 5 units? Yes, if you want, you can produce. Can you produce 4 units of Y? Yes. So whatever the number of units which is there inside this area, everything is possible. Got it? So for this area, we call it as feasible area. So this feasible option, feasible area, everything I will mark in the next question properly. Right? This question I am using just to give a rough idea. Right? Now you have 3 options. Now you have to check in which option you will get the maximum contribution. If you choose A, what will be the contribution? If you choose B, what will be the contribution? If you choose C, what will be the contribution? You have to check that. Right? In order to check that, we have to construct a formula which is called contribution formula. Contribution. Right? So your total contribution will be equal to from 1 unit of X, how much? 4. So 4X from 1 unit of Y, 5Y, correct? Correct or no? Total contribution will be equal to 4X plus 5Y. So this is your contribution formula, right? So if you go for this contribution formula, so now option A, how many units? 0 units of X and 6 units of Y. So 4 into 0 plus 5 into 6. How much? $30. Here, if you go for option B, 2.29 units. So 4 into 2.29 plus 5 into 4.28. Correct? How much? 30.56. If you go for option C, the point C, 4 into 4 units of X and 0 units of Y. 5 into 0, how much? $16. So you have 3 options to do the production. If you go for this option A, your contribution will be 30. If you go for this option B, your contribution will be 30.56. If you go for option C, your contribution will be 16. So which option gives you the maximum contribution? Option D. So this is your maximum contribution. So what is your optimum production plan? What is your optimum production plan? This is your optimum production plan. Clear? When it comes to real world context, we don't need to draw the simultaneous working also to find these two. Because in the graph itself, everything is there. It will filter it out. Got it? Any doubts? Actual how many units means? Yeah. So you mean here since it's in decimal places? Okay, usually it won't come in decimal place, but for this question, because of the values, it comes like that. When it comes to real world context, actually these will be the whole numbers. Got it? So, okay, write the answer. So draw this, after write this and mark these points also. Online students, any doubts? So people, but generally in most of the cases, the point where your limiting factors are getting intercepted, this point will be the optimum production plan in most of the cases, generally. Got it? So guys, whatever the messages you send it for the group chat. If you send it privately, it won't be visible for me. Okay. So okay. Now, what is this question number 2? Using this question number 2, I am going to teach the entire concept. I'm going to teach the entire concept. Everything I am going to teach using this question number 2. Online students, I hope that you can see my video and you can hear me. Can I get a final confirmation? Yes or no? Come on, make it fast. Yes, fine. Okay. So, question number 2. A Limited produces 2 products in 3 departments. Details are shown below regarding the time per unit required in each department. So, they are using 3 departments and they have given the details. The available hours in each department, the contribution per unit and the cost of each product they have given. So, department A, department B, department C. Product X and Y, how many hours it takes and the number of available hours is also given. And contribution per unit is given. It will be helpful to construct the contribution line. And cost per unit is also given. Identify the optimum production point if the objective is profit maximization. If your objective is profit maximization, now in the company there can be 2 objectives. One is maximizing the profit, another one is minimizing the cost. Okay. So what is your optimum production point if your objective is to maximize the profit? And what is your optimum production point if your objective is to minimize the cost? We have to find. So first of all, we'll do the requirement A. After we can move to the requirement B. Okay. Now, first of all, we have to draw the linear programming graph. Yes or no? Yes. We have to draw the constraint graph, right? In order to draw that, we have to construct the constraint formulas. Yes or no? We have to construct the constraint formulas. So how many departments are there? How many departments are there? 3 departments. Then how many formulas we have to construct? 3 formulas. So department A, department B, and department C. Correct? Right. So give me a second. Right. Okay. So now first of all, department A. Now when it comes to department A, tell me, you have 11,000 hours available, 11,000 hours. If you are producing only product X, how many units you will produce? It will be 11,000 divided by 8. Yes or no? Then it will be 8x. 8x. Correct? It's 8x. Plus 10y. 10y. Got it? Right. Equal or less than 11,000. Correct? Yes. Equal or less than 11,000. Department B. It will be, what's the constraint line? What will be the constraint formula? Guys, online also tell me what will be the constraint formula. Department B. 4x plus 10y. It will be equal or less than 9,000. 9,000. Correct? Right. Department C. 12x plus 6y equal or less than 12,000. Correct? Yes. Right. So these are the constraint formulas, correct? Right. So first of all, constraint formulas. Done? No? Now using these constraint formulas, we have to draw the graph. We have to draw what? Graph. Right. Now, first of all, in your writing book, write this constraint formula. Question number 2, write only the constraint formulas. Online also, do it with me. Done? Right. So now what we have to do? Now we have to draw the constraint graph, right? Constraint graph. Okay. So this will be our graph. Okay. So here you have your x-axis. So x-axis I am using to represent the number of units of x. Y-axis I am using to represent the number of units y. Okay. So first of all, we'll draw for what? We'll draw for department A. Now tell me, department A, you have 11,000 hours. If you are producing only x, how many units you will produce? How many units you will produce? If you are producing only x, how many units you will produce? 1375. So let's put that mark here. See, 1375. We have put the coordinate. If you are producing only product y, how many units you will produce? 1100. Okay. So here you will have the coordinate. Now what you have to do? You have to match it. Now you have drawn department A line. Okay, give me a second. Okay. Release this hand gesture. Okay. So this is your department A, right? Now you have to draw the department B. Department B. Okay. Now tell me, department B, if you are producing only X, how many units you will produce? 2250. So somewhere around here you have to place the coordinate, right? Okay. What the hell is this? Okay, 2250. If you are producing only Y, how many units? Shall I keep it? Shall I keep the zoom off? Was it visible? Okay. Okay. Then if you are producing only Y, how many units you should produce? 900. 900 units you should produce. So I have kept the coordinate. Now what you should do? You have to draw the line. So here you have the department B coordinate. Department B constraint line is there. Now what we have to do? Department C. So if you are producing only X, how many units you will produce? 1000 units. Here see, kept the coordinate. If you are producing only Y, how many units you will produce? 2000 units. Kept the coordinate. Now what we should do? We have to match the coordinate. Right. So now we are done with 3 constraint lines. Right. Now what we have to do? We have to identify the feasible points, right? So tell me what are the feasible points. Now here, if you look at this y-axis, you have 900, you have 1100, you have 2000. Can you produce 1100? Can you produce 900? Yes, because the department B is limited, but department A and C, you have unlimited resources. Yes or no? Can you produce 1100? No. Why? What's the reason? Because department B is limited. Department B, this line. Department B is limited. Can you produce 2000? No, you can't. Why? Department A is also limited. Department B is also limited. Right? If you look at this X, can you produce 1000? Yes. C is limited, but remaining two are unlimited. Right? C is enough. Can you produce 1375? You can't, because department C is limited. Can you produce 2250? You can't. Why? Because department A and C are limited. So what are the feasible points you have? Here you can produce what? You can produce 900 units of Y and 0 units of X. That is 1 point, right? That is 1 point. If not, here at this point, you can go for a mix. Yes or no? That is another point. Point B. Here at this point, you can go for a mix. Yes or no? This is another point. Here, 1000 units of X, 0 units of Y. You can go for the mix. Yes or no? Yes. Another mix. Right? So, this A, B, C, D, these are the what? Feasible points, if not feasible option. A, B, C, D, feasible points or feasible options. Got it? Got it? Right. Okay. So now what we have to do, we have to find the B. At B point, how many units of Y and how many units of X you have to produce. At the point C, how many units of Y and how many units of X you have to produce. You have to find it. Correct? Right. So before that, can you draw this? We'll go step by step. Yes, right. So now we are done with the feasible points. Now, in order to find the optimum production plan, we have to find, okay, A, at the point A, we know how many units of Y and X. At the point B, how many units? At the point C, how many units we have to find. In order to find the number of units at these points, B and C, what are we going to do? We are going to use the simultaneous equation, right? Simultaneous equation, right? So now tell me, first of all, B. When it comes to the B, point B, what are the two limiting factors you have at this point? What are the two constraint lines which are getting intercepted at this point? You see, department A, which is the blue color line, and department B, green color, which means at this point you have only two limiting factors, which are department A and department B. Department C is unlimited. Here see, you have extra excess amount you have. Yes or no? So here what are we going to do? We are going to use the formulas of department A and department B, and using those two formulas we are going to find the number of units. Got it? Right. So department A, so point B. So feasible point point B. Point B, right? So limiting factors are limiting factors. In other words, we can call it as constraint. Okay. So constraints are, I'll use the word constraint. Constraints are what? Department A and department B. Correct? Right. So now we have to use these two formulas, department A and department B. Right? So department A, I can name this as the first formula, first one. Department B, I can name this as the second one. Okay, second one. So now do we have any common factor? Yes, we have that common factor. So now what we have to do? So this is your first formula. This is your second formula. Now what we have to do? From the first formula, we formula. So first minus second. Okay, first minus second. So what 8x plus 10y minus what 4x plus 10y equal or less than what? 11,000 minus 9,000. 11,000 minus 9,000. Got it? Okay. So 8x plus 10y minus 4x minus it will become 10y equal or less than what? How much? 2,000. 2,000. Okay, right. Now what should we do? So if you take plus 10y and minus 10y, it will be eliminated, which means 4x equal 2,000. Then x equal, it is 2,000 divided by 4, right? Then x equal, it is how much? So 2,000 divided by 4, it's 500. So 500 units. 500 units. Got it? Right. So now we have found 500 units. Now what should we do? Now x we have found. Now the next one. Next one, what should we do? So next one, what should we do? We have to substitute. So what we can do? We can substitute this x equal 500 for one of these two formulas. Yes or no? So we'll substitute this x equal 500 for the second formula, right? For the second formula. So substitute x equal 500 to second. Got it? Right. So second formula, what is the second formula? It is 4x plus 10y equal or less than how much? 9,000. 9,000. Right? So 4x plus 10y. Now fine. Now 4 into x. So 4 rather right. 4 into 500. 500 4 into 500 Give me a second. Okay. So 4 into 500 plus 10y. 10y. Okay. So 4 into 500, we have to put it inside the bracket. Then it will be equal or less than 9,000. Equal or less than 9,000. Which means for 10y equal what? Equal or less than 10y equal or less than 9,000 minus 4 into 500. It is 2,000. It is 2,000. Is 2,000. Which means 10y equal how much? It is 7,000. Then y equal what? 7,000 divided by 10. So y equal what? So equal 7,000 divided by 10. It's 700 units. 700 units. Got it? So at the point B, what are the number of units? X equals 700 units. Sorry, X equal how many units? 500 units. Y equal 700 units. Y equal 700 units. Got it? Yes? Right. So now what we have to do? We have to mark this in our graph. In our graph, we have to mark this. So if you mark the values in the graph, here see X 500 and Y 700. Right. Okay. So the next one, feasible point. Feasible point C. Okay. So tell me, what are the constraints we have? In feasible point C, what are the constraints we have? What are the constraints? Department C and Department A. Department B is unlimited. Yes or no? Yes. So the feasible constraints are, what are the constraints? Constraints are Department A and Department C. Correct? So what are the two limiting factor line formulas we are going to use? Department A and Department C. Department A and Department C only we are going to use. So this is your first formula. This is your second formula. Second formula. Correct? Yes, right. Now, do we have any common factor here? No. So what we can do? What we can do? If we multiply Department C by 1.5, can't you make it 10? Multiply and see. 6 by 1.5. No. 9. 8 by 1.5. It's 12, I think. Yes, right. So here what we have to do? Here multiply the first formula, first one, by 2. Okay. What? Multiply by 1.5. 1.5. Okay. Right. So Department A. So 8x, if not 1.5 into 8x plus 10y. 1.5 into 8x plus 10y equal or less than what? 1.5 into 11,000. 11,000. Correct? Right. So 1.5 into 8x, how much? 12x. So then it will be 12x plus 1.5 into 10y, how much? 15y. It will be 15y equal or less than how much? 16,000. So 16,500. 16,500. So this will be your third formula. Third formula. Now what should we do? Now from the third formula, we can deduct the second formula, right? So third minus second. Third minus second, right? So okay. So third formula, that is 12x. Okay, this is the third formula, no? Right. So 12x plus 15y minus what? 12x plus 6y. Correct? Right. So equal or less than what? 16,500 minus 12,000. Correct? So plus 50 plus 12x minus 12x, it will be netted off, right? So if I write that one, it will be like this. Simple. Then it will be how much? Here how much? 4,000. 4,500. So 12x plus 12x minus 12x, it will be netted off. So 15y minus 6y, it will be 9y. So 9y equal or less than 9y equal how much? 4,500. So y equal, it's 4,500 divided by 9. So y equal how much? It is 500. 500 units. 500 units. Correct? Now what should we do? So substitute y equal 500 to what? Shall we do it for second formula? Substitute for second formula. Second. So if you write the second formula, it will be 12x plus 6y equal or less than how much? Equal or less than 12,000. So 12x plus 6 into 500 equal or less than 12,000. So here 12x plus how much? So 12x equal how much? 12x equal or less than 12,000 minus 3,000. Then x equal that is 9,000 divided by 12. So how much? Equal 9,000 divided by 12. How much? 750 units. So here in this situation, how much you are getting? How much you are getting? X equal how much? 750 units. Y equal 500 units. Got it? So at the point C, your X value, that is 750 units, Y value, it's 500 units. So mark the point in your graph. Done. Now there are 4 points, right? So A, B, C, D. Now we have to find what is the maximum contribution. What is the point which will give you the maximum contribution? Yes or no? Right. So in order to do that, first of all, we have to construct the contribution formula, right? So contribution equal, so total contribution, right? So contribution equal how much? So here for 1 unit of what? For 1 unit of Y, how much they are telling? How much they are giving? For 1 unit of X, 10. For 1 unit of Y, sorry, not for 1 unit of X, $4. For 1 unit of Y, it is $8. It is $8. Then it will be 4X plus 8Y. This will be your contribution line. Yes or no? Yes. So now what are the feasible options you have? You have 4 options. Feasible options, you have 4 options. Feasible options. Point A. In point A, what can you do? In point A, how many units of X and how many units of Y? Tell me. In point X, 0, 0X. In point X, you have 0 units of X and 0 units of X and 900 units of Y. This is your point X, correct? Point A. Now point B. Tell me. 500 units of X and then 750 units of 700 units of Y, correct? Right. Point C. 750 units of X and then 500 units of Y, correct? Point D. Point D. 1000. Point D. D. Okay. Don't make the errors. 1000 units of X, 0 units of Y. So these are the feasible options you have, correct? These are the feasible options you have. Okay. Okay. So feasible options done. Now contribution line also we have constructed. Yes or no? Now what we have to do? We have to find the total contribution. So point A, it will be what? 4 into 0 plus 900 into, sorry, 8 into 900, correct? Right. Then it will be 4 into 0 plus 8 into 900. How much? It is 7,200. Okay. At the point B, how much? 4 into 500 plus 8 into 700. 8 into 700. So equal. So 4 into 500 plus 8 into 700. It is 7,600. Correct? Right. Stop writing. At the point C, 4 into 750 plus 8 into 500. Online students, I believe that you can understand. 8 into 500. So if you do the calculation, it will be what? Equal 4 into 750 plus 8 into 500. It will be 7,000, right? Point D, 4 into 1000 plus 8 into 0. 8 into 0. Then it will be equal 4 into 1000. This $4,000. This $4,000. It is $4,000. Correct? Yes. So now we have found this thing. Now tell me, you have 4 options. Option A and option B, option C, option D. If you go for option A, you will have a contribution of 7,200. If you go for option B, you will have a contribution of 7,600. If you go for option C, you will have 7,000. If you go for option D, you will have 4,000. Now, which option gives you the maximum contribution? Which option gives you the maximum contribution? Option B. So this option gives you the maximum contribution. Clear? So this is your maximum contribution. So what is your optimum production plan? So the optimum production plan will be what? Point B. Point B. Got it? Yes? Right. So this option will give you the this thing, what maximum contribution. Yes? Any doubts? Any doubts? No doubts. So if you mark this in your graph, it will be, here see, point B, optimum production point for profit maximization. So optimum production point, if not plan, both are same. Optimum production plan for profit. For profit maximization. Got it? Yes? Right. Done? Done. Right. Okay. Now here, what did we do? Using the simultaneous equation, we have found the number of units and we have found the point at which you will have the maximum contribution. So eventually we have found the optimum production plan using the simultaneous equation. Yes or no? Right. In order to find that same optimum production plan, there is another way. We have something called ISO contribution line. ISO contribution line. Now using the simultaneous equation, here we have found this point B. Okay, B will be the optimum production point. Now there is another way, that is ISO contribution line. ISO contribution line means we have to draw a line. We have to assume some units of Y and some units of X, and we have to draw a line. Now let's say if you assume 300 units of Y, you will put the coordinate here. If you assume 600 units of X, you will put the coordinate here. You will match it. And you have to move that line towards the right side. You have to move that line towards the right side. When you are moving that line towards the right side, the last feasible point which it touches would be the optimum production plan. Okay. The last feasible point which it touches would be the optimum production plan for the profit maximization. Got it? Now here we have to draw an ISO contribution line first of all. Yes or no? Right. We have to draw that line and we have to move it towards the right side. We have to move it towards the right side. Then in order to draw that line, we have to assume a number of units. Okay, we have to assume a total contribution. Based on that only we have to find the number of units. When we are assuming the total contribution, you have to assume a contribution which will give you the units closer to the units which you have found using your coordinates, using the constraint lines. Which means now here you have to move the line towards the right side. No, here you have to move the line towards the right side, right? Towards the right side only you have to move the line. Then the total contribution which you are assuming, it should give you the number of units somewhere around here, like this, if not this and this, if not this and this. Got it? Yes, the total contribution which you are assuming, it should give the number of units, it should give the quantities which are closer to the quantities which you have found using your constraint. Now these are the quantities we have found using the constraint. No, you see, these quantities we have found using the constraint, right? So the contribution which you are assuming should give the quantities which are closer to these quantities. Y means it should be closer to 900. X means it should be closer to 1000. Y it should be closer to 900. I can tell no. Y it should be closer to 2000. Why it should be closer to 900? Because we have to move the line towards the right side. Then the line which we are drawing, ISO contribution line which we are drawing, it should be inside the feasible points. Yes or no? Yes. It should be inside the feasible points. Right? So for this question, we'll assume, let's say, we'll assume 3200. We'll assume 3200. That's the total contribution. Okay, we'll assume 3200. So okay. So if you assume, okay. So ISO contribution line, ISO contribution method. Okay. So assume the total contribution is 3200. Okay. Then what is your contribution equation? What is your contribution equation? It is C equal 4x plus 8y, correct? C equal 4x plus 8y, right? Then C, that is 3200, correct? C, that is 3200. Then 4x plus 8y, right? Now tell me, so this is your contribution line. Okay, this is your, not this is your contribution line. So now tell me, if you are producing only X, how many units you will produce? If you are producing only X, how many units you will produce? So therefore X, how many units? It is equal 3200 divided by 4, correct? Yes. Y, how many units? It is equal, if you are producing only Y, how many units you will produce? 400, correct? Which means 3200 divided by 8, right? So now you have to mark this in your coordinate. So X 800 by 400. So if you match this, this is your ISO contribution line. Now what you have to do, you have to keep a ruler. Without changing the slope, you have to move that line towards the right side, right? If you move that line towards the right side, now here, let's see whether we have any kind of ruler here. Okay, so no ruler. So if you move this towards the right side, it will be, first of all, it will touch the point C. After it will touch the point A. At last, it will touch the point B. If you do it, the last point would be this one. Your ruler will come and stop here. Got it? So what is the last feasible point which our contribution line touches? The point B. Are you getting the same answer? Yes, you are getting the same answer. So this is another way. So do remember, when it comes to the ISO contribution line, you have to draw a line, and without changing the slope, you have to move that line towards the right side. In the same slope, in the same gradient, you have to move that towards the right side. Then the last feasible point which that line touches would be your optimum production plan for the profit maximization. So do remember, in order to draw the ISO contribution line, when you are assuming the total contribution, you should assume a total contribution which will give you the quantity which are closer to the quantities which you have already found. Got it? Yes, right. So write this note, put the heading ISO contribution line and write this note. So write like this. I write the heading like this. ISO contribution. So write the note, write the heading ISO contribution line and ISO cost line. Write the heading like that, ISO contribution line and ISO cost line. Write that point. When we are assuming the total value, when we are assuming the total value, when we are assuming the total value, to draw the ISO contribution or cost line, when we are assuming the total value, to draw the ISO contribution or cost line, ISO contribution or cost line, comma, a value should be assumed, a value should be assumed, a value should be assumed which will give the production quantities, which will give the production quantities, which will give the production quantities which will give the production quantities closer to the quantities, closer to the quantities, closer to the quantities we have found using the constraints, closer to the quantities we have found using the constraints, using the constraint. Right? The next point, then the ISO contribution line, then the ISO contribution line, then the ISO contribution line should be moved toward the right side, should be moved towards the right side, should be moved towards the right side, maintaining the same gradient, while maintaining the same gradient, while maintaining the same gradient. Okay, while maintaining the same gradient. Full stop, continue. The last feasible point which it touches will be the last feasible point which it touches will be the last feasible point which it touches will be the optimum production point for the optimum production point for the profit maximization. Optimum production point for the profit maximization. Optimum production point for the profit maximization. Correct? Yes? Okay. The next point. ISO cost line. ISO cost line. I'll teach ISO cost line. First of all, write the point. ISO cost line should be moved to the left side. Should be moved to the left side. People should be moved to the left side means you will draw the cost line somewhere here and you have to move it to the left side. In other words, moving towards the origin, moving to the zero value. Correct? So inside the bracket towards the origin. Inside the bracket towards the origin. Towards the origin. Correct? Towards the origin, close the bracket, continue writing. Maintaining the same gradient. Maintaining the same gradient. Full stop, continue. The last feasible point, the last feasible point, the last feasible point which it touches would be the, which it touches will be the last feasible point which it touches will be the optimum production point, optimum production point for cost minimization. Optimum production point for cost minimization. For cost minimization. For cost minimization. Okay. Yes, right. So now you can write this. Okay. After that, you draw the ISO contribution line and move it towards the right side. So here, yeah, what you have to do, you have to do one more work. Now here I have drawn this and dotted line. You draw like that, and if you have space in your graph, because you are drawing everything together, no, I am hiding certain, no, right? If you have space, it would be better if you put an arrow like this, looking for moving for rightwards. Okay. Right. So ISO contribution method, right? That is done. Now, so we have found the optimum production plan using the simultaneous equation and using the ISO contribution method. So what is the requirement A? Identify the optimum production point if the objective is profit maximization. That is done. Now what is the requirement B? What is the requirement B? Identify the optimum production point if the objective is cost minimization. So even though profit maximization, cost minimization, okay, whatever the method, you have to end up with all these four feasible points, right? Yes or no? Now what are the four feasible points you have? Right. So in the contribution, in requirement A, what did we do? We calculated the total contribution for each point and we found we selected the point which will give you the highest contribution. Here in cost minimization, what we should do? For each feasible point, you have to calculate the total cost and you have to select the point which will give you the lowest cost. Lowest cost. Clear? So in order to do that, we have to construct a cost formula. In the contribution, we had that contribution formula. No? So here you have to construct something called a cost formula. Right. Cost formula. Okay. So total cost. So cost equal. Now tell me, in order to produce 1 unit of X, how much is the cost? In order to produce 1 unit of X, how much is the cost? $10. Then 10X plus for Y, how many? 15Y. Correct? Yes. So your cost will be 10X plus 15Y. Now what are the four feasible points you have? A, B, C, D. Correct? Right. So the feasible points you have, that is Okay. Okay, fine. So now A, tell me at the point A, how many units of X and how many units of Y you are producing? So it is 10 into 0 plus 15 into 900. 15 into 900. Then how much you are getting? So then it will be equal. So equal 15 into 900. How much? 13,500. Now point B. 10 into 500 plus 15 into 700. 700. Then it will be equal 10 into 500 plus 15 into 700. How much? 15,500. At the point C, 10 into 750 plus 15 into 500. Then how much? Equal 10 into 750 plus 15 into 500. How much? 15,000. At the point D, 10 into 1000 plus 15 into 0. Then how much? So equal 10 into 1000, it will be 10,000. So here what's happening? If you go for the point A, your total cost will be 13,500. If you go for point B, your total cost will be 15,500. If you go for point C, your total cost will be 15,000. If you go for point D, your total cost will be how much? That is 10,000. Now tell me which option, which feasible point gives you the lowest cost? Huh? Option D. So this is giving you the lowest cost. Lowest cost. Got it? So tell me what will be the what is your optimum production plan for the cost minimization? Tell me what is your optimum production plan for the cost minimization? Come on. 1000 units of X and 0 units of Y. Therefore, the optimum production plan for cost minimization. Cost minimization. X how many units? X 1000 units. Y how many units? 0 units. Got it? Yes? Right. Correct? Right. Now, in order to find the optimum production point for profit maximization, we had the ISO contribution line, right? For the cost minimization, we have something called ISO cost line, which means we will draw the ISO cost line and we have to move it towards the left side. You have to move it to the left side, towards the origin. Then the last feasible point which it touches would be the optimum production point for the cost minimization, right? So now here we have to move the line towards what? Towards the left side, no? Yes or no? Towards the left side. Then the line should be outside the feasible area or left side the feasible area. For this area we call it as feasible area. So the line which we are drawing, the cost line, should be outside the feasible area or inside the feasible area. It should be outside the feasible area. So we have to draw the line somewhere around here. Then only we have to move it towards the left side. Yes or no? So here also, when you are assuming the total cost, you have to assume a cost which will give you the quantities which are closer to the quantities we have found using the constraints, right? So for this question, we'll assume a cost 20,000. How much? 20,000. So ISO cost. So assume that the total cost is 20,000. Okay. Then your cost equal how much? What is the formula? 10x plus 15y. Then here 20,000 equal 10x plus 15y. Yes or no? Then if you are producing only x, how many units you will produce? That is 2000. If you are producing only y, how many units you will produce? That is 1333. So let's keep it as 1333. Okay, got it? Right. So here yours I'll units, ne? Right. Now what do you have to do? You have to mark this point in your graph and you have to draw the line, right? So x 2000, y 1333. So x 2000, here see, y 1333. This is your ISO cost line. Now what do you have to do? You have to move it towards the left side. So when you are moving it towards the left side, the first point which it touches would be B. Second point would be C. Third point would be A. The last point would be D. Right? So it would be like this. Then your optimum production point for cost minimization would be option D. Got it? Yes? Yes or no? Got it? Right. Right. So now the next one here. Here, now what is our optimum production point for profit maximization? Point B. At this point, what are the limiting factors you have? What are the two constraint lines which are getting intercepted? Department A and Department B. For these two, we call it as binding constraints, right? The resources which are limited at the optimum production point, we call it as binding constraint. If you take Department C, it is not related, right? You have excess amount. So for that one, we call it as non-binding constraint. Non-binding constraint. Clear? And also Department C people, for this area, if you look at this area, for this area we call it as slack, because here at this area you have excess amount of Department C. Yes or no? Yes or no? The resource which is not fully utilized at the optimum production point, that is known as slack. Got it? So here what will be the slack? Department C will have some slack. That now available is how much? Department C available how much? 12,000, but we would have used around 11,000. So 1,000 is balance, slack. Got it? Right, fine. So people, so now here I showed the binding constraint and non-binding constraint, right? So for this area, the area which is above the optimum production point, we call it as slack. We call it as slack. Okay. So this area we call it as what? Slack. Okay. So can you mark this area in your book? Done. Right. So that's it with the graph. So what else is there to be covered? So binding constraint done. So these constraints are known as binding constraints. The resources being used is equal to the resource available. Non-binding constraint, the resources which are not fully used. Okay. Slack means the amount of resource that is underutilized. Slack means the amount of resource. How many hours you have underutilized. That is known as slack. Right. So surplus. What is the meaning of surplus? Surplus means it is simply, now you have a minimal demand of 400. The demand is only 400. But the constraint suggests you to produce 450. So that 50 is there. That is surplus. Okay. Right. So for the slack, write this question. For the slack, write this question. Using the information in question 2, using the information question 2, calculate the slack for each department. Calculate the slack for each department. Right? For each department. So let me do it. Department A. Department A. Now, when it comes to department A, what? For one unit of X, you have to use 8 hours, correct? Right. Now, what is the optimum production plan? How many X you have to produce? 500. 500, correct? Right, 500. Plus, for one unit of Y, 10. Like that, you have to produce 700, correct? Correct or wrong? Correct. Then equal, so usage how much? That is 8 into 500 plus 10 into 700. 11,000 is your usage, correct? How many hours are available? It is equal to 11,000. So available is 11,000. So what's the slack? What's the slack? You have 11,000. You are using all 11,000. So is there any balance? No. So what's the slack? Slack is 0. Slack is 0. Okay. Slack is 0. Okay. So like this, now you have to do for all 3 departments. Okay. So department, sorry. Okay. So department B, for one unit of X, how many hours? For one unit of Y, 10. Then 4 into 500 plus 10 into 700, correct? So 9,000. Available is 9,000, correct? Then what's the slack? 0 slack. 0 slack. So available minus usage. Available minus usage. Okay, fine. Now department C, for one unit of X, how many hours? 12 hours. For 1 unit of Y, how many hours? 6 hours. Then it is 12 into 500 and then 6 into 700. Available how many hours? 12,000. So what's the slack? Slack is, well, 1,800. Okay. Fine. So now tell me in which resource we have the slack? In department C. In department C only we have the slack, which means we have the balance amount. Got it? Right. So, right. Now the next one. So slack is done. So I have given a question. A company produces two products X and Y, both of which require skilled and semi-skilled labor. Both grades of labor are expected to be limited in the following month, and managers have formulated a linear programming model with the below information. So objective function is given, skill labor hours is given, so 2000 hours available, right? And semi-skilled labor hours is given. So X and Y I have given equal or less than 150 and 80. What does it mean? Here I have given X 150. What does it mean? That means X has a demand of 150, Y has a demand of 80. Equal or less than? Got it? Maximum demand of X is 150. Maximum demand of Y is 80. The optimal solution has been identified as the intersection of the skill labor hours constraint and the demand constraint for product X, which means now here for X you will draw the demand line. It will be a vertical line like this. For X it is 150 now. You will draw a demand line. Okay. And Y you will draw a demand line like this. However, you will have the limiting factor constraint lines also. The optimal solution they are telling, that's the point where your skill labor hour constraint and the demand constraint, those two constraints are getting intercepted, those two constraints are getting cut, right? Which of the following resources will have slack at the optimal production level? Now tell me, now what are the binding constraints here? Skill labor hours and the demand of X. Binding constraint, will those have slack? Binding constraint means with the resource which is fully utilized. Will those have slack? Any? No. So first one, skill labor, is that correct? No. Semi-skill labor, is that correct? Yes. Wait, skill labor hours and semi-skill labor, is that correct? No. Neither skilled or neither semi-skilled, it is not correct, right? So which resource will have the slack here? Semi-skilled labor. So the correct answer is option B. Option B. So underline that answer. Option B. A company sells two products X and Y. It has constraints related to three of the resources required in the manufacture of X and Y. So you are producing two products X and Y. Resources are A, B and C. So A line they have given, B line and C line they have given, right? It has drawn the following graph to represent the linear programming problem. An ISO contribution line is also given. The company wishes to maximize the profit and has determined that the optimal point is where the constraint lines A and B cross. Where the constraint line A and B cross, which means A and B, this point. This point. Correct? Right. Let me draw it a bit bigger. This point. Here, A and B, right? Which of the following statements are true? Resources A and B are binding and will have a surplus. In a binding resource, will we have surplus? No. Resources C is binding and will have slack. Okay, resource C will have slack, but is that binding? No, non-binding. Resources A and B are binding and will have zero slack. Correct or wrong? Correct. Resource C is non-binding and will have slack. Correct or wrong? Correct. So C and D are the correct answers. Got it? Right. Okay. Now the next one, we have something called shadow price. Shadow price. Now what is the meaning of shadow price? Now here, if you look at this, you have three constraints. Department A, Department B, Department C. Correct? Right. Now what are the two constraints which is related to the optimum production point? What are the two constraints? What are the two constraints? The constraints are Department A and Department B, correct? Yes. Now, shadow price means in order to get 1 unit of that scarce resource means the limiting factor. In order to get one more unit of that scarce resource, how much extra you will pay? Now, if there are any limiting factors, you can't purchase the limiting factor for the normal price. Even though it is limited, someone will be there who has that resource, right? He will ask for an extra payment, an additional charge, right? So for that extra amount, we call it as premium. On top of the normal amount, if the normal amount is 50, he will charge around 65. So that extra 15, we call it as premium. So how much premium you will pay maximum? How much extra amount you will pay in order to get that one more unit of extra resource? In this example, now what are the binding constraints here? Department A and Department B. In order to get one more hour of Department A, how much extra he will charge? In order to get one more hour of Department B, how much extra he will charge? Simply, shadow price means in order to get one more unit resource of that binding resource, binding constraint, how much extra you have to pay, maximum. Right? Now, how to calculate it? Any idea? How to calculate it? So here we have to find the shadow price for Department A and Department B. Shadow price means simply in order to get one extra unit of your scarce resource, how much extra you have to pay. So how to calculate? Using the contribution. So first of all, we have to calculate the total contribution if we increase the resource by 1 extra hour. So first of all, we'll calculate for Department A and then Department B, right? Now these two are the resources, no? These two are the resources, right? So shadow price. So these two are the resources. So now what we have to do, this is for question number what? Question number 3, ne? No. For question number 5. For question number 5. Okay, right. Now, we have to calculate the contribution if you have one extra hour of Department A, which means Department A will be available will be 11,001 hour. Department B will remain the same. Department B we calculate separately. Department A we calculate separately, right? Now available Department A is 11,001 hours. Available Department B is 9,000 hours. Correct? Right. So now tell me. So now what we have to do? So this is your first formula. and this is your second formula. Do you have a common factor here? Yes, 10y. So what can you do? From first formula, you can deduct the second formula. First minus second. So here, 8x plus 10y minus 4x plus 10y. Okay. Equal or less than what? 11,001 minus 9,000. Correct? Which means 8x minus 4x. Correct? Equal or less than what? 2001. Correct? Right. So 4x equal 2001. Then x equal how much? X equal 2001 divided by 4. So x equal 2001 divided by 4. It is 500.25. So let's keep it as 500.25. 500.25. Correct? Right. So x we have found. Now what we have to do? We have to find y. So what we can do? Substitute x equal 500.25 to what? We'll substitute for formula 2. Second formula. So formula 2, right? Formula 2 equal or less than, right? Then it will be 4 into 500.25, correct? Plus 10y. 10y. 10y equal or less than how much? That is 9,000, correct? 9,000. So 4 into 500.25, how much? 2001. 2001. So 2001 plus 10y equal or less than 9,000. Right? Or less than 9,000. Then 10y equal how much? That is 9,000 minus 2001, how much? 6,000? 6,000. So equal 9,000 minus 2001, 6,999. Then y equal how much? Y equal how much? Equal divided by 10. This 699.9 units. Got it? Yes. So we'll keep it for 699.9 units. Okay. So now we have found. So if you get extra 1 hour of department A, you will have x 500.25 units and y 699.9 units. Now we have to find the total contribution. You have to find the what? Total contribution. So total contribution. So contribution equal, total contribution equal. So people, tell me what's the contribution formula we have learned? What is the contribution formula we have learned? 4x plus 85. So C equal 4x plus 8y, which means here C equal 4 into how many units? 500.25 plus 8 into 699.9. Then C equal how much? So equal 4 into 500.25 plus 99, sorry, 8 into 699.9. How much? 7,600 and 600.2, which means 7,600.20. Got it? Yes, right. So previously, how much was the contribution? Previously, at your optimum production point, how much contribution you had? 7,600, right? So the previous contribution, okay, fine. So previous contribution, how much? 7,600, right? Current contribution, how much? It is 7,600.20, correct? Then tell me by how much your contribution is increasing. By how much your contribution is increasing? 0.20. So your contribution is increasing by 0.20. Then how much extra? No. So if you get 1 hour of department A, your contribution will increase by how many units? How many dollars? 0.20. Then maximum, how much extra amount you will pay? 0.20. Will you pay more than 0.2? You might pay less than 0.2, but what is the maximum? 0.2. Got it? So what's the shadow price? 0.20. Okay, right. So incremental contribution. So your shadow price will be, so this will be the shadow price. Got it? Right. So now what you have to do, you write this answer. After that, calculate the shadow price for department B as well, which means you have to make that 9,000 as 9,001 and you have to work out X units and Y units and you have to calculate the contribution. Do it. So, so first of all, write this. So tell me the answer for department B, yeah? Done. So how much? 0.6 the 7th. So So shadow price for department A we have calculated. Department A. Okay, right. Now shadow price for department B, right? So now what we have to do, simply let me copy paste this. So department A make it 11,001 and here it is 9,001, correct? Sorry, 11,000. 11,000, okay. So first minus second you have to do it. So for x, okay, fine. So from 11,000 you have to deduct 9,001, correct? Then how much you will get? Sorry, 11,000 minus 9,001, it is 1,999. So 1,999 divided by 4, it is 499.75 units. Substitute x equal 499.75 to second one. So if you do that, here it will be 9,001. Here 4 into 499.75. Then how much? 4 into 499.75, how much? Huh? 1,999. So 10y equal 9,001 minus 1,999. How much? It is 7,002. Then y will be 700.2 units, right? So now contribution, it is x 499.75, okay, and y, sorry, y it is 700.2 units, right? Then how much? 700.2 units and 499.75. How much you are getting? 7,600.60. What is the previous contribution? It is 7,600. So how much extra you are paying? 0.60. 0.60. So what is the shadow price? 0.6. So this is the shadow price for department B. Got it? Online students, any doubts? Guys online, any doubts? Online, any doubts? Hello, online students. These buggers don't reply also. Right, no, right. So people, now when it comes to linear programming also, there are some limitations. Right, so the first one, linear relationship must exist. So you are assuming that straight line relationship is there. Second one, it assumes that there is a single quantifiable objective. So which means at a time you have only one objective. It will be either maximizing the contribution, if not cost minimization. But when it comes to real world context, we can have multiple objectives, right? Third one, when there are a number of variables, it becomes too complex to solve manually and a computer is required. When there are multiple variables, number of variables, number of limited resources, 4 to 5 limited resources, it is very difficult to use this linear programming manually. We need the computer. Next one, it is assumed that the variables are completely divisible. Single value estimates are used for this, used for the uncertain variable. So completely divisible means we are assuming that the variables will be able to divide. We will be able to divide the variables, like the whole numbers, proper values will be there. But when it comes to the real world context, there will be improper values which cannot be divided and everything will be there. Yes or no? Yes. The next one, it is assumed that the situation remains static in all other aspects. Is that correct? No. The next one, it is assumed that the scenario is short term. So linear program we are using for short term because we are not considering the fixed cost. Fixed cost we are ignoring. It is a problem, right? Next one, non-financial data in product mix decision. Now, based on the financial confusion, we found the product mix, right? What are the non-financial aspect? Customer value. Sometimes customers will prefer product B, but according to your contribution, product B might be 0. So how are you going to take the decision? The next one, competitor plans for competing products. And the next one, the length of time that a particular resource will be scarce. So we learn scarce resource will be there, limiting factor. For how long will it be limited? You can't tell that forever it will be limited, no. For how long it will be limited, right? The next one, opportunities to use alternative resources. You will be able to use the alternative resource if one particular resource is limited. Yes or no? Yes. The next one, expect a demand for a product and the ethical impacts of removing the product. So these are the non-financial thing you have to consider. Got it? So with that, we are done with the linear programming as well. Put a tick.